Hi everyone, welcome to my another lecture on that is singularities of a complex function. Singularity. How to find the singular point actually. In this lecture, we will discuss about that singular points or singularities of a complex function. Very important topic for B.Sc and B.Tech as well as NET and GATE exam. So what is singularity of a complex function? A complex function fz, complex function, it is a complex function fz, that is, what is complex function? Fz equal to u plus vi, as you know, where u equal to x function of xy, v equal to function of xy. So if complex function fz is failed to be analytic, okay, what is analytic function? That is satisfied by CR equation, okay. At z equal to z0, then we say z equal to z0 is a singular point or singularity of fz, singular point or singularities of fz, okay. If a complex function fz is failed to be analytic at z equal to z0, then we say z equal to z0 is a singular point or singularity of fz, okay. So in shortly we can say a point at which a function fz is not analytic. In shortly, a point at which a function fz, a point at which a function fz is not analytic, okay, is known as singularities of fz, singularity of fz. You can say like that. For example, suppose z equal to fz equal to, suppose fz equal to, if I say fz equal to if I say fz equal to 1 by x z minus 3, 1 by z minus 3, fz equal to 1 by z minus 3. Now you see fx is fz here is not defined, fz is not defined at z equal to 3. That means if we put this equal to 0, that is z minus 3 equal to 0, then z equal to 3. So if we put z equal to 3 over here, this becomes infinity, that is fz is not defined. So we can say fz has a singular point, therefore we can say fz has a singular point at z equal to 3, at z equal to 3. So at z equal to 3, fz is not defined, and if I say a real life example of singularity, it means something different. Real life example, singularity means, what do you mean by singularity? Means it means something different. If I say suppose in a room there are 50 students are there, real life example I am saying for better understanding of singularities. If I say in a room there are 50 students, only out of this 50 students, only one of them wear tie. Okay, that means that is particular student who is wear tie, he is different from others. So that is the student who wear tie, that is known as singular. Point is that. Okay. Similarly, if I say all 50 students were tie, one were tie, one student were not tie, that means that student is known as singular point. That student, something is different. One student does not wear tie, other students wear tie, that means that student is known as singular point. Now if I say all students are same, all students wear tie, that means there is no singular. That means there is no different. There is all students same type. All students are tie, so no singularity. All students are not tie, that is no singularity. Only singularity means something different. Something different. Like one student are tie out of 50, then that student is known as singular point. Understand? So that is, if I say now some points about singularity. That is singular point. Singular point, here you see only z equal to 3 is the singular point. How to, when it is algebraic function, then denominator part take 0, then that find the value of z, that point is known as singular point. This is the procedure to get singular point. Suppose if I say another example, as fz equal to, say fz equal to z minus 3 by z into z minus 5 into z minus 2. So this, in this example, so what is the singular point? You take the denominator part is 0, that is fz is not defined when z into z minus 5 into z minus 2 equal to 0. That is z value 0 to 5. So 0 to 5, these are the singular point. These are the singular point. Here singular point is 2, 0 to 5. So that means it is finite. We can say finite means this is countable. We can count how many singular points. If so, what I am saying, I mean to say singular points may be finite, may be infinite also. Okay. Singular points may be finite, may be infinite. Here it is finite, here it is finite. Now if I say another example, so these are the singular points 0 to 5. If I say another example, that is fz equal to, say fz equal to 1 by sine z. Fz equal to 1 by sine z. You see, if fz is not defined when sine z equal to 0, that is 0 means sine pi, we can write n pi. Sin n pi equal to 0, so z equal to n pi. N belongs to integer. So here, if we put n equal to 0, 1, 2, 3, dot, so many things. So there are infinite number of singular points for different values of n. For different values of n, we are getting the different values of z up to infinity. So here we are getting, here is finite. Here we are getting infinite number of singular points. Okay. So sometimes we are getting finite number of singular points. Sometimes we are getting infinite number of singular points. Okay. Very important. Now that means what I'm saying here, that is singular points may be finite or it may be infinite. Now, suppose if a function, this is very important. If a function, this is very important point. If a function is nowhere or anywhere analytic, then we say it has no singular point. This is very important. No singular point. If a function is nowhere, that is, it is never analytic or it is all time analytic, then we can say there is, in that case there will be no singular point. For example, if I say an example like suppose fz equal to z square, fz equal to z square. So here z square, fz equal to z square is always analytic. Is always analytic. Why it is always analytic? You can check by CR equation. If it satisfies CR equation, that is different. It is always analytic. So no singular point. Singular point. No singular point here. That is, if a function is always analytic, then there will be no singular point. Similarly, fz equal to example 1, example 2, fz equal to say fz equal to z mod z square is not analytic anywhere. Is not analytic anywhere. Is not analytic anywhere. So we can say it has no singular point. It has therefore so no singular point, because this is never analytic. The function is never analytic. That sense, so no singular point. Singular point. So try to understand this. What I said here. I said here, if a function is nowhere analytic, this never analytic. This is never analytic, or every time analytic, then in that case there will be no singular point. You have to remember. Again, you have to take another example. Say fz equal to, say another example 3, fz equal to z bar. Z bar is not analytic anywhere. Is not analytic anywhere. So no singular point. No singular point. How to get the singular point? Just you take the denominator part equal to 0, then find the value of z. That is known as singular point. The value of z is known as singular point. Okay. So this is all over actually. That is singularities of complex function, or you can say singular point. In my next video, next lecture, this is the first lecture, part 1. This is part 1. In my next lecture, I will explain the types of singular point. Just I am saying one thing, that is, if the singular point is finite, then we can say it is isolated singular point. If the singular point is infinite, then it is called non-isolated singular point. That is isolated singular point and non-isolated singular point. So in my next lecture, I will explain what are isolated singular points, how many types of isolated singular points. Then in that lecture, that is in part 2, I will explain. So till then, bye bye. Keep watching, sharing and commenting this video with your friends. Thank you.